Hi everybody, Dr. Pingle here with a lecture on OpenStreetMap. Some of you may have heard of OpenStreetMap, but I find that most people, even within geography, still haven't really used OpenStreetMap very much, and it's a shame because OpenStreetMap is essentially a Wikipedia for spatial information. So one of the big challenges in GIS is getting a hold of the spatial data that you're looking for, and oftentimes you've got organizations like the federal government that do a pretty good job of aggregating data. Many cities and counties do the same. But in many parts of the world, it's much more difficult to get a hold of data. And there's really no guarantee that the cities and counties are going to be mapping things that users are interested in. So oftentimes rivers and streets are mapped very well, but sidewalks and other features in the environment may be mapped much more poorly. So OpenStreetMap is a great way that users can contribute to kind of building a map of the world, and so that's what we're going to talk about today. OpenStreetMap is fairly new. It was started in 2004 by Steve Coast in the United Kingdom. This is one of the reasons why OpenStreetMap edits and the completeness of the map tends to be a little bit better in Europe generally. So it's very popular in Germany too. In the United States, it's fairly detailed. It really kind of depends on where you go. Major cities tend to be mapped very well. Places outside of that can vary a good deal. So a good portion of DeKalb has been mapped, and they've brought in a lot of data from things like Tiger, so they didn't start from scratch. But we're adding new things all of the time. The idea is that people create and edit vector data. So while we'll take a look at this, and it looks sort of just like a Google map, it really is the vector data that's underneath all of it all that's the most interesting part. So we would consider the rendering of that map separate from the vector data that's underneath of it. It was directly inspired by Wikipedia, so I often call it Wikipedia for spatial information. And it really relies on the user base to contribute information. So rather than taking existing data and bringing it in, what they want is for users and contributors to upload GPS traces or digitize based on aerial imagery. OpenStreetMap's really been growing in popularity. So this is a graph showing the active contributors to OpenStreetMap per month, starting from 2005 all the way to just a little bit after 2013. And you can see sort of this steady growth pattern, more and more contributors as time goes on. And these are a similar sort of a graph. This is OpenStreetMap registered users. So the number of registered users has been going up exponentially. And the reason for this is, people get very excited about it. They share the news and people sort of create an account, log in, and maybe make a couple of edits. In comparison to the last edit, or the last graph rather, not all of these are actively contributing, but even so, that number is increasing as well. This is a map, or excuse me, this is a graph showing contributions by area. You've got a couple of major cities here, so you can see Berlin and Paris and Moscow, quite a lot of contributions. Cairo, Seoul, relatively fewer. So the basis of OpenStreetMap is that it's all user contributed. This is because official sources like the Ordnance Survey in the United Kingdom are proprietary. So in the United States, we have the USGS that has kind of taken the lead in collecting and disseminating a lot of the data sets that we have here. They were directly helpful in establishing the national map. But in Europe, there's a tradition where instead of sort of giving away the data for free, the federal government would try to recharge any users of that data and trying to basically make money off of it to fund itself and to fund its projects. In the United States, we've taken a different view. We figure if the public is paid for collection once, then they shouldn't be charged for dissemination also. And so this is one of the reasons why OSM got started in Europe. They really didn't have the same level of free data sources that we have in the United States. And so the ethos of OSM is that users use their experience, tools, and some donated imagery to create accurate vector maps. It used to be probably that much of what was contributed was GPS. These days, probably most of what gets generated comes from digitizing off of orthophotos. The map that you see when you interact with OpenStreetMap, these are rasters, not vectors. So just like Google Maps, when you bring that up, what you see is it's a raster image, and you can kind of get a sense of that when you zoom in and out. You can sort of see the pieces sort of go out of focus, and then you'll see the new pieces come in. And if you watch very closely, and we'll demonstrate this in the applied part of the lecture, you can see these things tile in these little squares that come in. So these are what are called map tiles. They're just sort of like the tiles on your floor, and the computer renders these tiles at different zoom levels. So the closer the zoom to the Earth, so to speak, the more little tiles it takes to do it. Farther away, the tiles are bigger, and you don't need as many of them. What these are what these tiles represent is sort of the rasterized version of vector data. So as you take the data that represents roads and building outlines and lampposts and whatever else is inside OpenStreetMap, a renderer is going to take those vector layers and it's going to turn those into a raster, just like you can use vector to raster transformation tools within ArcGIS. And it's going to save those and it's going to serve those back up to users that visit OpenStreetMap on what's called a tile server. So you can get a hold of these map tiles in a number of different ways. Esri itself is actually a map tile server. Google serves these tiles to its own websites. But there's a company that has kind of gotten pretty big within the geoscience community recently for serving these kinds of data, and that's Mapbox. So Mapbox serves up these OSM-based map tiles along with a lot of other things. They're really kind of making a name for themselves in the cloud computing realm of GIS. And all of these are really, really beautiful maps. So I would encourage you to follow this link and to take a look at some of these. You can kind of see some outlines of them here. Some of them are really amazing. So there's some good high contrast images. There's some sort of good ones that look like they were kind of drawn in ink. Some fantastically good ones. There's even one that is a map for pirates. So that's a fun one, and take a look at it sometime. This is an example of what the DeKalb, Illinois administrative boundary looks like within OpenStreetMap. So we've opened up OpenStreetMap, and we've done a quick search for what's called a relation. We'll talk about that in a second. But this is basically the city boundary of DeKalb, Illinois. It's a complex shape. This was actually sourced using Tiger data, which if you take a look on the sidebar there, you can look about midway down. It'll say source Tiger line 2008 place shapefile. So a lot of the publicly available data has been kind of bootstrapped in to OSM, which obviously saves a lot of time and headache. So that's great. This is an example of the zoomed in version of the DeKalb city boundary. And here you can kind of see what I mean when I say that the data underneath OSM is a vector. But what you look at when you're interacting with it, if you just go to openstreetmap.org, is sort of these raster tiles. We'll show you a way to sort of look at both at the same time, which is how I generated this image. But you can see sort of this crisp orange line running through the image. That's the vector data. And then you can see sort of pixelated version of what could just as easily be Google Maps data. Underneath of that, that's all cloudy, blurry, and this is because I caught it at sort of the right time before it could tile back in. So this is sort of demonstrating the difference between the raster map tiles and the vector layer. All of this stuff is directly editable online. So if you go to openstreetmap.org, you can sign up for an account and you can start editing almost right away. There are a number of good walkthroughs available for that, which you'll be looking at as part of your assignments for this lesson. Really interesting way to contribute to geospatial information on the web. We'll talk about this in more detail when we get to the lab, but there's a really nice Wikipedia page associated with OpenStreetMap. So if you go to wiki.openstreetmap.org, you can get some really good descriptions about how all of this is supposed to work. And the documentation that's associated with OSM is really, really amazing, especially given that it's kind of this distributed user project. So they've done a really good job of sort of trying to explain how things work. This is an excerpt that defines what the elements are in OpenStreetMap. So it's really important that you have a good understanding of what these are. And it's one of the great things about using OSM is you get a chance to sort of explore GIS and data storage and databases in a way that's different than ARC. And so you can start to compare and contrast the different approaches to managing spatial data. So we've got three different kinds. We've got nodes, ways, and relations. Nodes are what we would usually think of as points within ArcGIS. Ways is what we would ordinarily think of as roads, but it actually corresponds to polygons as well. And then we've got a third category called relations that sort of aggregate these things together. So in a sense, ways are lines and polygons. Relations handle sort of this multi-part of multi-part lines and multi-part polygons. So we'll take a close look at those as we move through. This is an example of a node. So a node is a specific point on the Earth's surface defined by latitude and longitude. Within OSM, we don't worry about things like projections. That's not really a GIS. So you can't really do analysis, you can't do buffers, things like that. But what it is this great spatial data repository. Nodes are going to have things that, just like they do within ArcGIS, they're going to have attributes. And we would call these tags. And so whenever we add a point, we do much more than just sort of add the geometry or add the location. We add information about what that point is. Maybe it's a name, maybe it's a description. So we've got a couple of examples here. Highway equals traffic signals. You'll learn a little bit about the sort of style that goes along with naming OSM tags, but you'll get the hang of it, and usually people kind of come to like it. So highway equals traffic signals is one. Power equals tower would be a way to sort of represent a tower. And the idea here is that, okay, these names may be a little bit arcane. It may seem a little bit strange. Once you see it in practice, it'll probably seem a little less strange. But it's still going to be very particular. If you want to mark a traffic signal, this is how OSM wants you to mark it. And the reason for that is if we're going to build a community database, we really need to set some standards so that we're all sort of tagging things in the same way. Otherwise, none of the data is going to operate together. And as it is, when you're using a wiki, you can't guarantee that people are going to use these things. So sometimes the naming schemes can still fragment. But this is why you use the wiki, why you try to name things in the convention that goes with them to make sure that other users can actually use the data that you're creating. So that's a node. This is a way, and the symbol associated with a way. Notice that ways are going to represent not only polylines, but also polygons. So we're going to sort of use a single data structure to represent those two kinds of things. Notice that there's a restriction, so it's an ordered list of between 2 and 2,000 nodes. So we don't want these things to get too big. If we do, we need to sort of think differently about how we're going to record that stuff. And probably that 2,000 node limit will increase as time goes on, and it may have increased already, since the last time I took the screenshot. Notice though that at the bottom it says that areas with holes or boundaries of more than 2,000 nodes cannot be represented by a single way. Instead, the feature will require a more complex multi-polygon relation data structure. So that means that we can have polygons, but we can't have polygons with holes in them. So we need to be a little careful about that. On the other hand, we can have polylines, so you could have sort of a forked road all represented as the same thing. Relation is our third major type. So we can think of this as sort of like a container that's gonna aggregate these other two pieces together. So there are lots of good examples of this, but my favorite is like a bus stop. So a bus route rather. So a bus route is going to be composed of the route that the bus travels, but also the bus stops that go with it. So bus stops are going to be represented as nodes, and the route that the bus takes is going to be represented as a way, and all of that is going to be kind of glued together by this idea of a relation. Even without editing, you can explore the vector data by turning on the data layer from the toolbar. So we'll do this live in the applied portion of it, but this is a really cool thing where you can sort of like take a peek under the hood and see the vector data that lives underneath the sort of typical raster generation. Like I said, you can take OSM and you can start editing things directly in the browser, and this is kind of what I encourage people to do when they first get started, as just sort of a way to kind of get their feet wet. It's certainly doable, and in fact, a couple of the things are a little bit more convenient when you're editing from the web page. But in general, and here I've sort of imagined that I've clicked on that edit arrow and looked at these different options. In general, people prefer editing with what's called remote control. There are a couple of versions of this, but by far the most common is JosM. So JosM is the Java OpenStreetMap editor. It runs in Java. So one of the great things about this is that it runs on any platform. It doesn't need to be installed. You can just sort of Google for JosM, and you'll run across this page. You can download JosM tested.jar. It'll have a version number attached to it. But this is basically just a runnable file, and as long as you've got Java installed on your computer, which almost everybody does, it's going to work just fine. So you don't need a Windows installer, you don't need the Mac OS X package. Download that jar file, and you'll be in good shape. You can also use a web launch version of this. I typically don't, but if you wanted to, you could. This is an example of what JosM looks like on the Northern Illinois University campus. So here, this looks a lot like sort of like ArcGIS. You've got a raster image underneath that happens to be aerial imagery from Bing. Microsoft has done a pretty good job of trying to donate a good bit of their imagery that they have to try to get their name out there within the open source mapping community. So it's kind of a neat play on their part. But on top of that aerial photo, you can see sort of these vector layers, and you don't have to know what they are yet, but it looks a lot like a regular old GIS. There are a number of really good resources to learn more about OSM. So if you go to learnosm.org, there are a number of tutorials there. I'll ask you to work through some of those as part of the assignments for this course. But lots of really good resources there for you. There are also editors available for the open source GIS package QGIS, as well as ArcGIS. So we'll take a look at those as well in the applied part of the lecture. Really handy way to start digitizing. I still prefer using JosM rather than any of those, but it's certainly helpful if you want to try to get your data into ArcGIS. Sometimes those editors are the easiest way to go. I still never do that myself, but a lot of people do that. One of the coolest things about OpenStreetMap is it's a lot more than just 2D. So we've got a number of different representations that include 3D models. So this is a rendering of osmbuildings.org. Really cool way to look at 3D buildings within the OSM platform. And interior spaces can be modeled in much the same way. This is very much hit and miss, and the specifications for doing this are still sort of in development, but it certainly works well enough for people to do a pretty good job getting some of the buildings rendered within the map. So all of this data is up online. I've sort of talked a little bit about how you can contribute to it using the web editor or using JosM. How do you get data back out of it? Well, every time you use JosM, you're actually going to be downloading pieces, but it's actually even easier than that. So any of the data that exists on there, you can use a service called Overpass to grab that data. I don't need you to know all of this stuff in detail, but one of the things that I wanted to emphasize here is that the Overpass API, which is the Application Programming Interface, is basically run by, let's just say, volunteers. People who have a sort of an interest in making sure this project works, have essentially donated compute time, and do this for free. So when you go to download this data, one of the guidelines for this open source kind of mentality is to not download too much. Download whatever you need, but don't just download anything and everything. This is an example of what overpass-turbo.eu looks like. So this is a web interface that you can use anytime to kind of download some specific OpenStreetMap data that you might be interested in. And when you go to download this stuff, you have a number of different options that you can use. So I bring this up because I wanted to tie back into the previous lecture. We talked about vector-based formats, and you can see this stuff showing up very nicely out in real life. So it is really important for you to know much more than just geodatabases and shapefiles. So we've got three different things that are kind of commonly used. So we've got GeoJSON files, which is what you see there on the right, GPX files, which are these GPS track files that have become sort of a standard, and then KML, which is the keyhole markup language. This interfaces with Google Earth and a lot of the other Google Map tools. So when you go to get that data, you can get KMLs, you can get GeoJSONs. Both of those have to be converted in Esri to be able to use them. So there are tools available that we've used previously. So KML to layer you could use to get these things in. Remember that both KMLs and GeoJSONs can hold multiple geometries. So when you do the conversion, you can sometimes run into trouble if you've downloaded nodes and ways in the same KML or the same GeoJSON. So you do have to be a little bit careful about that stuff. Otherwise, rather than using sort of the stock ArcGIS tools, you can actually use more free resources online. So one of the things that I like to do in this course is to kind of open people's eyes to the number of free geospatial tools that are up there on the web. So Ogre is one of those. So Ogre's job is to translate various vector formats from one to the other. So you can use these to take a GeoJSON file and to turn it into a shape file. So that's what's going on there in the image at right. So if you are running into trouble trying to get either data from a KML or a GeoJSON that you downloaded from Overpass, and you're trying to get it into Arc, go ahead and try to use those Arc tools first. They get better all the time. But if that doesn't work, don't give up. You can look around for some of these web resources. You can try to use QGIS to do the conversions. Lots of really good options there. So keep your options open. One of my favorite applications of OpenStreetMap is the Humanitarian OpenStreetMap team. So this is a volunteer organization that sprouted up a number of years ago. to try to leverage the power of OSM to try to sort of crowdsource a lot of geodata and to get it into the hands of first responders to an emergency. It's really easy to get involved. You can just sort of sign up. There's a really good tutorial video which I'll link to, and it's a great way to get started. Fun way to sort of spend 20 or 30 minutes helping out, and it's kind of in this way that it's not too much of a burden on any one person, but we can all sort of contribute what we can. This is kind of a quote that summarizes the mission of the Humanitarian OpenStreetMap team, abbreviated HOT, H-O-T. When major disaster strikes anywhere in the world, HOT rallies a huge networks of volunteers to create online the maps that enables responders to reach those in need. So it's really a fantastic way to help out. So the website for that is hotosm.org. We'll include this as part of the practical side of this unit. So you'll see this again. You can take a look at once you're there, you can take a look at the ongoing projects. So these are a couple of the recent ones. So they do a fair bit of disaster mapping. So when something particularly sudden and awful happens, they can respond to that. But they also do some community development. So they work on sort of getting ahead of the game. One of the big programs is mapping in Indonesia. And you can read a lot more of these online. I've included a link here. A lot of these stories are really interesting. And again, you'll be working, part of the requirement of the assignment is that you contribute a little bit to a Humanitarian OpenStreetMap team project. Those projects themselves are distributed via the OSM tasking manager. Again, you'll sort of get the hang of it when you start working with it, but if you go to, it can be a little bit difficult to navigate the hot OSM site sometimes. So if you just go to tasks.hotosm.org, it sort of takes you right to the parts where we're really looking for volunteers to do something today. This is what that looks like. This is a little section of a map of Swaziland. And basically what they do is they divide the problem area up into a grid. They give you some instructions, which you can see over there on the left. Once you've read all of those instructions carefully, you can get started, and you're going to get assigned a grid cell that you can kind of work through. They'll try to be as specific as they can. They know that crowdsourcing is kind of a tricky business. They want to make sure that everybody's on the same page. So they try to provide very detailed instructions, project-specific mapping notes. They give you information. A lot of times what happens in these is we're trying to map buildings as best we can, so that they have some idea of sort of the magnitude of the population and the structures that have been affected. So one of the great things about OSM is that it's really easy to get started. You really just need to go to openstreetmap.org and create an account. So there's a little sign in the upper right. To get going, you'll want to follow the tutorials at learnosm.org, and we'll link these more extensively in the assignment part. And if you're really interested in contributing to the Humanitarian OpenStreetMap team, let me know. I've got my email here. And we'd love to have you in as part of the team. We have a couple of volunteers. We get together when something happens to try to do our little part. There's a lot more to the world of crowdsourced geodata than just OpenStreetMap, although that's my favorite. Wikipedia does a really good job of crowdsourcing geospatial data. So increasingly, as a part of every web page that has any kind of geographical connotation at all, they're going to do things like include the coordinates. So this is the city of DeKalb, and you can see that in the panel on the right, the coordinates are given. So really great to have geography embedded in so many web pages. This one is kind of maybe starting to die off a little bit. This is a project called WikiMapiya. Again, sort of touted as another Wikipedia-like map content. Just didn't quite reach the critical mass that OpenStreetMap did, but it still has a pretty active user base. One of the big differences between WikiMapiya and OpenStreetMap is the OpenStreetMap tends to focus a little bit more on the physical and administrative part of the environment, whereas WikiMapiya is a little bit more flexible with regards to the different kinds of information that can be included. And then finally, one of the things that people don't really realize is that Google Maps actually has an interface that people can submit corrections to. So Google knows very well that it's very difficult to maintain an accurate database like this. They know that buildings open and close, or businesses open and close, and roads do the same, and so the environment is constantly changing, and so people have to update the maps. So rather than try to make sure that they have enough employees to do the job, they have just provided a mechanism so that people can contribute those corrections themselves. So if you just Google Google Map Maker, you'll run across this, but the URL is given here. Unlike OpenStreetMap, where effectively we track the changes, we're a little bit cautious about how those things get implemented, but it's essentially an open process. In contrast, Google Map Maker is very much protected. So you can submit a correction, but it gets approved by an editor, and then as long as that seems like it makes sense, then that'll get folded in there. So we'll have a look at that in the assignment part of the lecture as well, or the unit rather. So there's your quick introduction to OpenStreetMap and some of the related technology. Hopefully you found this interesting, and I hope you'll enjoy the applied portion of this as well. Thanks very much.